to SilviCast, the podcast about all things silviculture. I'm Greg Edge, silviculturist retired with the Wisconsin DNR Division of Forestry.
And I'm Brad Hutnick, Wisconsin DNR silviculturist, still working until they take the car keys away. Yes, Greg, I am not a quitter, and we're your hosts for today's show. Guten Morgen, Gregor, and welcome to Season 7.
I know. Can you believe it? Time flies, Brad.
Well, and apparently time flies a hell of a lot faster for you, my friend, because, wait for it, I'm setting up the big reveal here for the audience, but you're making a significant life change, right? You've decided to become a Vikings fan?
No.
Okay,
No.
okay, maybe not severe. So wait for it. Greg is hanging up his cruising stick, and he's turning it in for a pickleball paddle. Well, all right, whatever.
That's what you tell me.
Yeah, but you are officially retiring from the DNR, correct?
Yes, that is true, but you make it sound like I'm ready for assisted living or something.
Michelle tells me that she has to help you every day. She basically refers to you as an assisted living situation. So just so you know.
Okay, we won't go there.
Yeah.
I like to think of it as semi-retirement. I am still doing SilviCast after all.
No. Once you pull the plug, you're done, my friend. Cell division stops. The decay cycle begins. I mean, we all are senescing, but you're basically in that steep decline for senescence at this point. So I don't know. You should maybe start thinking about like nursing homes and maybe check out some walkers. I've seen some good ones. I'll watch for a walker for you on Marketplace. It'll turn out.
Thanks, Brad. I don't think that'll be necessary. Yes, I am retiring from Wisconsin DNR, the silviculturist role here, which, by the way, is the best job on the planet.
Agreed.
I am leaving that, but I hope to remain active in silviculture. I just need to figure out exactly what that looks like.
Maybe based on your life's experience, you could equate it to something, I don't know, like a rotting log is what it looks like.
Hey, wait a minute. You're only 5 months younger than me.
But that was a hell of a 5 months, my friend. I mean, I don't know what happened between when you were born in what must have been, like in 65 and me in 66. But I think the world changed. Like it was a hell of a hard 5 months, my friend.
Well, yeah, I did have a very difficult early childhood.
Yeah. Well, Appleton and all.
Yeah, it was. Yeah. It was really rough. But I do deserve some level of respect, Bradley. So please, from now on, you can refer to me as Greg Emeritus.
Well, you know what? I'll give you Greg Emeritus, but, no matter what, the decay cycle doesn't stop for anybody.
Well, I am glad you're focused on decay because you're really going to enjoy the guest today. Today on SilviCast, we'll be talking with Mark Harmon, who is a professor emeritus in the Department of Forest Ecosystems and Society at Oregon State University. And Dr. Harmon has spent decades researching tree mortality, decomposition of wood, and the management of coarse woody debris in our forests.
And, this is really going to be a fun discussion. I think this is a great topic. And it actually kind of feels like it should be our Halloween episode. But wait for it. How did you snag this speaker?
Wah, wah, wah.
All right, whatever. Thank you to our season sponsors, the Family Forest Carbon Program and the Nelson Paint Company. You make the SilviCast world go round. Mark Harmon, welcome to SilviCast. So for our listeners who don't know maybe a lot about you, tell us a little bit about yourself and your work.
Well, I'm a professor emeritus at Oregon State University, so I'm retired, although I'm still active in writing and reviewing and even doing field work. But I'm a forest ecologist. I worked at Oregon State for many decades, and one of the main things I worked on was the role that dead trees played in ecosystems. And I studied all kinds of aspects of how trees die and how they decay away and how the functions they perform over time in an ecosystem. And so that's been one of my main emphases. And it continues today.
Mark, we've been wanting to do an episode on morticulture for quite some time, and reading through the papers, it was really intriguing. When I first heard that term, I was like, wow, that's so cool. And then you coined the phrase, so I think we've come to the right place. Greg, when did we first start talking about this?
I don't know. We've been talking about that term, kind of half jokingly, half serious, and
Yeah.
for quite a while, and thought, oh yeah, we got to do an episode on that. So, Mark, we were really happy when we came across some of your papers and your research from your career. So, I was just wondering, maybe that would be a great place to start. Can you explain a little bit by what you mean by that term?
Yeah, I'm glad to do so. I think I'll start with its origins, which actually was a bit of a joke because we just moved into a new building at Oregon State University, and my adjacent office was occupied by a fellow who had his normal name tag, but he also had a brown and white sign that said silviculturist. And I thought to myself, well, if he's a silviculturist, then what am I? And I thought, oh, maybe I'm a morticulturalist because I was studying dead trees. And I thought, well, I think I'll have a green sign, but I never did get the green sign. But then I thought, and I had some opportunities to write a paper on, well, what would dead wood management look like and what would you call it? And so I decided on morticulture, keeping that idea. And it is kind of, it's deliberately a funny idea to get people to think. But basically, it's raising trees to become dead trees. And so you're growing trees to die. Now, silviculturalists, when they have trees harvests, also raise trees to have them die. But nonetheless, that's the idea, to deliberately grow trees to have them die, which at the time was a pretty radical idea and probably still is.
Yeah, we kind of half joked that we should do this as a Halloween episode, but any time of year is really good. So,
yeah, I love, Mark, in reading through that paper that you mentioned, you kind of brought it out. Like, I think a lot of times we think about just leaving trees behind, going, well, I left some trees, therefore I'm going to have some dead trees in the future. But it's more complex than that. And I love the term you said that a dead tree isn't actually dead, which to me is kind of like, it's kind of mind blowing when you think about, like just how alive a dead tree can be, which is, I don't know, like kind of what's that other phrase? What is the sound of one hand clapping? How alive can a dead tree be? What do we mean when we're talking about a live dead tree?
Well, what I was trying to get at with that concept, again, is to get people to rethink, because people have ways of thinking about dead trees that are quite ingrained, and sometimes they're pretty erroneous, although I understand why they haven't. So, for example, a dead tree is a waste. Well, it's a waste if we can't use it, but do the termites view it as a waste? I have some doubts on that. So anyways, the idea was, okay, if we were to scientifically decide whether an object was alive or dead or more alive than another one, what we do is we determine what percentage of that object was alive. So when you do that for trees, you find out that 90% of most trees, they're dead as doornails. The outer bark isn't alive. It's a protective layer. There's a thin inner bark, which is a couple of percent. That basically is the bark and wood cambium and the phloem. Sapwood is mostly tubing, plumbing, if you will, to bring water and nutrients up to the leaves. That's 90% dead in many species. You add up all these live parts, including the leaves and the fine roots, and you end up with something like 10, 12% of it's alive. And it's dominated by one organism. Well, a dead tree actually could be up to 25% alive. If you look at it, you'll see all these fungal hyphae in it. You'll see small arthropods, insects, nematodes, there's bacteria. There's every form of life is in a dead tree. By that I mean major, divisions of life. So in terms of the number of cells that are alive and the number of organisms participating in it, a dead tree is definitely more alive than a live tree. And so the point is that it's not a resource that's wasted or unused. There are many things that live in it and depend on it. And it's a major part of what we call the detrital food web. People mostly think about the sort of the herbaceous green plant, Bambi, etc., wolf food web, but most of the energy that goes through a forest is actually through that dead detrital food web, which is quite alive.
That's a really fascinating way to think about and look at dead trees in the forest. And I think about kind of traditionally in forestry, our focus is elsewhere on the living trees and keeping those trees healthy. Do you think foresters need to kind of rethink their assumptions about deadwood in the forest? I mean, what has been your experience around that working with other foresters?
Well, it's quite a range. Some people, foresters, have been quite attuned to, well, we need to provide habitat, say, for bluebirds or woodpeckers or other obvious wildlife species. Some, their immediate thought is I remember going out on a field trip and a guy pointing out, that's a Lexus, and that's he just was naming, luxury automobiles that were left on the ground to make his point that that was money. So there's a diverse set of views. I think one way to interpret that, though, is that there are multiple objectives to managing forests. Some are mostly for timber production. Hopefully, they can provide habitat and other benefits. Some are pretty much for biological conservation. One of the things is you have to view the forest management not as there's one particular way you manage a forest. You manage it for specific objectives. Since the objectives are different, the management is likely different.
Mm-hmm. Greg, we see that a lot around here, right? Like we see, but here, I think it depends on a perceived value of that individual tree. Like if I were looking at a walnut here in southern Wisconsin and it were dead, I think there would be a higher probability of that thing coming out versus if it's like, say, one of our lower valued species, then there might not be much of an issue with it. It seems like it's probably related to, it's going to be like objectives, but it's going to be really nuanced all the way through kind of our management.
Yeah. I think foresters are used to looking at different objectives throughout the forest. And so, like you say, Mark, it kind of depends on what those objectives are and what that focus is of those foresters. I guess what I was thinking about was just traditionally in our silviculture, it's been focused on those living trees and capturing that mortality, we say, in
Yes.
terms of things like thinning from below to capture the mortality of stem exclusion stage or something like that, or salvage. As soon as we have a windstorm, we're out there looking at salvage operations to capture that mortality. And so I kind of think about that. And you've suggested in some of the papers you wrote that, maybe we should kind of shift our focus from looking at trying to maintain a set or a static amount of deadwood in the forest, because we know that that's good, to something that's a little more dynamic approach in terms of accounting for, I think you said earlier, Mark, something about managing for that deadwood or that flow of deadwood in the forest. And so how can foresters go about doing that? What I think about is they need information or data on that to think about it that way. Is that research available for foresters to look at? And how do they go about that?
Well, I wish there was a lot of information available, but there isn't because this general area is understudied. But some general principles. One of my criticisms of this more static approach is, you're in there, you do something, you meet a standard, problem solved, is sort of multifold. One is that the amount of anything, say in a box, a pool, is highly dependent on how much is coming in and how much is going out. That's a more dynamic approach. So when you have standards, it's like, let's do something. now or check, see if we hit a standard, problem solved. Well, no, the problem isn't solved because it's the dynamic changing system which has inputs and it has outputs. So that's one of the things people have to think about. So what would the inputs be? It would be mortality, either through natural mortality, disturbances. I guess those are natural too, but a range of mortality sources. Some that are deliberate in the management, like felling trees or topping trees to create snags or felling them to create logs, exposing, not killing them, but exposing trees to hazards, if you say, that eventually they will succumb and die and provide that input. But you also need to know about the output. And for management, that might be more about the different stages of decay that occur, because they will not stay in one state of decay. They will progress. Different stages have different functions. I've thought about it a lot as actually decomposition rate. In fact, I have a 200-year-long study that I just worked on recently to determine those decay rates. So some things are very hard to determine, other things less. Anyways, that's one of the big things that people have to think about, that it's a dynamic thing. It's not a static thing. Guidelines are fine, but they have to be in the context of what will it be 10 years from now, 20 years. And that's an analogy to silviculture, because silviculturists do not think, well, they think about next year, but they think about the whole life cycle of a forest. And that's the kind of approach that has to be applied. So silviculturists know how to do that. They just need to think about it for something else other than just live trees.
Yeah, and we have looked at that input of dead trees as maybe like an event, right? So at a timber sale, at something where we basically put something on the ground. But then I have to admit, I think in a lot of, Greg, I don't think I've seen very many plans that have actually called for provision of deadwood, standing or down, through the remainder of a rotation or through the life of a stand.
Yeah, and we tend to, we're guilty here. We tend to lean toward those static guidelines that you mentioned, Mark, of 4 oven dry tons per acre of biomass left behind in a biomass sale, or X number of snags per acre after a timber sale, that sort of thing, rather than thinking about the input and the output and the rates.
Yeah.
And probably the differences between forest types too, right? Different forests. You work in the Pacific Northwest. I'm sure there's probably different rates there than we have in some of our systems.
Yeah, there are differences. So, we always have this dichotomy of generalizations, which are good, but then when you apply them, you have to look at your local context to figure them out. The other problem with these standards, and I think there should be some kind of guidelines like that, but they really depend on the function you're shooting for. And so is it going to be habitat for insects? Well, they don't really need big pieces, at least in terms of length. Are they runways for small mammals? They need large pieces to form a decent runway. Are they habitat for small birds or large birds? Large birds will need larger diameter trees, et cetera, et cetera. So the standards tend, if you did that for all those things, they'd be super complex. So they tend to be numbers of pieces, maybe some minimum length, maybe it's a volume or mass, but it tends to be a very general description, and there's nothing wrong with it. But it's kind of like a silviculturist just saying, I'm going to just grow trees. Well, they might be growing trees for telephone poles, pulp, framing, plywood, etc. Furniture. They actually think about what is this tree likely to be used for? And that's going to influence how I approach it. I might have a tighter stand to reduce knots if that's important. If that's not important, if I actually want knots for furniture or whatever, maybe I have a more open stand so I can get bigger knots. Or more figure on the wood or something. It's taking that idea and just applying it to the dead wood. It's not just dead wood. What's the function you're trying to enhance in the ecosystem? And the more specific you can be, the better. Unfortunately, there's not a lot of information on that, but what I found, if there's no demand for information, information is not generated. So
Yeah.
if there's a demand, people will start to generate it in multiple ways, sometimes formally, sometimes informally, but it will be generated.
I love the idea that we kind of have to be nuanced in how we approach this and talk about it like a culture, right? So we're actually working through this. It could be by cover type that we may need to think about it. It may be by maybe that stage of development. And I imagine that must play a role for, like, say, lots of different cover types for where is that particular stand in its stage of development? How much wood would you actually need for deadwood, or how much would you expect to see at that point in the life of the stand?
Yeah, and that's another problem with the standard. After a major disturbance, it could be from humans cutting, there's a lot of slash left, but certainly after, say, a beetle fire, something like that, drought-related mortality, there's going to be a spike in the number of dead trees or the volume of dead trees. And because we have an output process, it's going to decrease through. And so we tend to have spikes, and then it will decrease over time. And unless there's more input, you just have to be aware that that's the phenomenon. So there's kind of a range that would be, it's not a threshold minimum standard. There's really kind of a dynamic range that's occurring. That's why when someone says, and I'll get into this a little bit, we want to manage for a healthy forest, I don't really know what that means. I know what a lot of people mean, but they're talking about a production forest. But a perfectly healthy forest has had some patches of fire-killed timber, and there's a huge amount of stuff there, and then some other place that hasn't been disturbed in a long time, doesn't have much. There's quite a range in what we might call a normally functioning landscape. So that's ideally what you'd be trying to mimic.
I know, Brad, I know you probably want to ask this question, so I'm thinking, but I'm going to ask it.
Yeah.
So Brad's always thinking about kind of fire and fire disturbance in systems, and I'm wondering how does that play in to this idea of morticulture in a system that maybe would have experienced frequent low severity fires that would have consumed a bunch of that deadwood. How does that factor into sort of that consideration of that flow of deadwood through that forest over time?
You beat me to it, Greg. Good question.
Sorry.
Yep, it's good.
Okay, so I'm going to fall into that cliche of the professor just keeps making things more and more complicated. But I don't think it's outrageously more complicated. So you've mentioned one aspect of the fire, and that would be to consume some of the woody detritus. So that's a factor. So you've got, in addition to decay and decomposition, you've got an additional loss through the fire. And that's going to tend to alter the nature of the material left. It will tend to consume the more decayed, punky wood that will burn directly but smoldering, and less on the more solid, less decayed wood. So it's going to alter the kinds of material that are out there. Depends on the severity, of course. And usually fires, particularly wildfires, are highly variable in their severity. And so we hear a lot about these huge fires in California. They are huge, mega fires and high severity. But actually, in those mega fires, only 25% of them were high severity. So fires tend to be highly variable, so they're going to introduce patches where some trees are killed and some trees are not killed, and some high consumption of dead wood and not. So it's adding a lot of variability. And the next thing is It's interesting. You can take the ratio of dead trees to live trees, and you can use that in some interesting ways. Typically, say in your forest, that probably ratio is something like 10%. So the volume of dead trees would be about 10% of the live trees in a mature forest. Well, then think about all the dead wood being consumed. All you have to do is kill 10% of the trees and you've replaced it. And so fires generally, there probably are some very, very low severity fires that just consume the dead wood. But most of them are consuming the dead wood, but they're also killing trees. And in a low severity fire, there might be small trees, but there could be patches where it gets kind of hot and kills a bunch of trees. Probably what fire is really doing is altering the form of the dead wood, making it more solid, less decayed, than it is actually altering the amount in total.
Because you have experience in both the eastern United States and western, are there any fundamental differences that foresters would need to think about if they're working in any of those areas, or is this pretty much like that would apply across the board?
That probably, the fire thing specifically, probably applies across the board. And when we talk about fires, we have to talk about many, many, many fires, hundreds,
right,
to get trends. They're highly variable.
Right.
And so any particular fire could be quite different from another. Mm-hmm. So that's one thing we have to be aware of. But I think the main difference in terms of processes are that the longevity of the live trees, the lifespan seems to be longer in the West, particularly the Pacific Northwest. One of the reasons there's so much live biomass is not because the trees grow super fast. They can grow super fast. But most of it is they have a really long lifespan, so they have a really long time that they can accumulate volume and mass. So that's one thing in the East. Could be a half to a third the average lifespan out in the Northwest. The other thing is the decay rates tend to be higher. They could be like 5 times higher in some cases. And the form of decay tends to be different. In conifers, you get a lot of what's called brown rot. These are fungi that don't break down lignin. They leave that cubical red-brown stuff you see in a stump, like in a pine stump or spruce stump or something like that. There's another system, though, that breaks down lignin. It's called white rot, and they leave this white stringy material. It's the cellulose. And they're breaking down the lignin. And those are very common in hardwoods, things like aspirin, alder, a lot of things, ash trees, whatever. And those will completely disappear. They won't form that kind of cubical brown rot, which eventually turns into, this is the scientific term, guys, red mush. But if you dig through the forest floor, you see this brick brown red mush.
Yep.
And they won't form that at all. And they'll literally just disappear. You won't even, in a while, even know that they're there. Maybe you find some branch stubs or something, but so that has a different effect on the soil development. You won't get that big duff layer that you might get in a conifer forest. So there's some things like that. Higher rate of mortality, higher rate of decomposition, and different pathways of decomposition are the main things that I see that are different.
Mm-hmm. Yeah, I could even see, Brad, just here in Wisconsin, what you're describing, we could see those kind of differences because we have quite a range of forest types here, from the oak hickory forests of the central Appalachians to the conifer boreal stands in the north. So, yeah, I know what you're describing there and can see it across the state here.
Yeah, so those are the differences, and there's some general information about decomposition rates that give people. There's an idea of how long a dead tree object might last. There's a lot less on things like rates of snag fall, but I imagine that will be quite high in your area, and even less on sort of the decay state progress.
Mm-hmm.
Some areas like in Scandinavia, they've got quite a decent set of models that actually tell you how long it's going to stay in each stage of decay.
Hmm.
And if they have different functions, then you can get a sense of, well, how's my function changing and how's my balance of decay states, and do I need to alter that to achieve what my goals are?
Yeah.
I know you've talked previously about this idea that we get mortality with pulses or with this disturbance. So we've been talking about fire as one of those, but we could have lots of different disturbances that would create these pulses of mortality and these pulses of wood that would come through. Is there a good way to anticipate how much we're going to get, like out when, so we get a particular disturbance, how much mortality or how much wood we would actually anticipate moving into the deadwood pool?
Let's first talk about this sort of idea of a continuum of mortality,
Yeah.
because people have tended to think about mortality as normal or regulated or something like that. Background, there's all these terms for mortality. It's sort of within the stand that's caused by competition or maybe occasional disease versus this disturbance, which comes in and restructures the stand, might kill a lot of trees. And that could include, human intervention as well as natural things like fires and windstorms and beetle kills and stuff. That's kind of useful, but it actually starts to get in the way of what's really happening, because there is a continuum of mortality that we need to think about. And it goes from something as little as a branch dies or needle dies, that's mortality, to individual trees dying, to patches of trees dying, to major areas and landscapes dying because of some disturbance or some climate event or something, to regional catastrophes caused by asteroids. I know that sounds bizarre, but when you think of it in the big picture, it's this continuum of mortality, some of which can be more anticipated. Typically, the smaller it is, the more you can anticipate it as being inevitable. The larger it is and more extreme it is, the less we think about it. In fact, I'm sure some viewers are like, asteroids, it really. But in the lifespan of trees, which is 350 million years, there have been over 30, continental scale wipeouts of forests from asteroids. So at certain levels, it's quite routine. So that's one thing to think about. I think for us, though, when we're talking about fires or windstorms, some of that can be anticipated as a large probability. What's the likelihood? That will not necessarily explain a particular place. And so you can get a sense of what the odds are, but they're typically not high. They're like 1%, 10%, depends on what it is. So a better way to think about it is, when it does occur, be prepared for its inevitable occurrence. But when it occurs, don't just respond, oh, we got to salvage that, we've got to do this XYZ. In the context of your management objectives, think about whether this is an opportunity or what part of it is actually an opportunity that now appears for you, that nature has done some work for you and helped you move along that pathway. Sometimes nature has done this and it's moved you off your pathway, but sometimes it's moved you on your pathway. So that's what I think you can anticipate the odds. They're not high. Better to, be aware of that, but also be aware that this is not always negative. And that's the thing. Mortality is usually viewed negatively. And there's a number of reasons for that. Most of us don't want to leave. We're not keen on mortality. It certainly interferes with certain forestry objectives. I get that. But in itself, it's just a process. It has no values. It's just a process. It might help you, it might hinder you, but it doesn't always hinder you.
Season 7 of SilviCast was made possible thanks to sponsors like the Family Forest Carbon Program. The Family Forest Carbon Program pays landowners to improve the health of their land and increase the long-term value of their property. The program equips landowners with the resources and support to implement sustainable practices that help them reach their own goals for their woodlands, while also improving the health of their forests and our planet. To learn more about how you can access these benefits for your forest, visit familyforestcarbon.org. In terms of what you said, we can't avoid some of these things and we can't control them. So I think about, we had a major tornado here in the northeast part of the state several years ago.
Yep.
Yeah.
Yeah, that was, disastrous and maybe not wanted, but to look at it as an opportunity, it also afforded some opportunities to maybe put some different things on that landscape, to change some structures and some habitats. If you can't control it, look at it as an opportunity. It seems like the optimistic way of looking at things.
Yeah, and don't get me wrong. I mean, there could be safety concerns that are created.
Right.
It could be interfering with, an economic objective that's important for that particular piece of land. So I'm not saying, oh, just, okay, throw up your hands, we'll just drift along, in the cosmos,
Yeah.
take it wherever it takes us. But it doesn't often pay to fight everything. I've got a colleague, he's a silviculturist, who's talked about, command and control attitudes versus a more give and take attitude. Do you try to force the system the way you want it to go, or do you see where there might be opportunities? So his example would be, it might be disappointing to not have uniform regeneration over an area. Maybe some areas are understocked. But what if you want some of that habitat? Well, it's created that opportunity to you. So why should you be fighting the system to get that restocked when it might be actually providing you an opportunity for some more open habitat that generally might be lacking in your landscape?
Yeah.
Yeah, I love that idea. It's not inherently bad. It's how we approach it and then how we can use it or how it fits into our management. And I like that idea. You have those scales of it, right? So, like Greg, we have listeners in Iowa who had a derecho that took down a lot of trees. We have stuff in northern Wisconsin. But then you get, what's the name of that one? It was the Tunguska event in Siberia, blew down, basically it was an asteroid that kind of,
Yes.
it was a larger one, basically flattened a big chunk of Siberia, like early 1900s. That's a completely different issue there, but it's still kind of like, well, if that's natural, we can work with it.
Yeah.
So Greg, we'll be looking for
Yeah.
we'll be out there singing the song next time we see trees dying, going, hey, it's just our approach to it now, and basically we just have to make sure we integrate it into our management.
Yeah. I'm going to hope not for the asteroid part landing on my head, but
Well, not on your head, but on somebody else's trees, it's okay. So it's all right.
Yeah. Mark, I'd like to kind of step back a little bit. We have a lot of listeners who are field foresters and just think about maybe some ideas and some thoughts around how we can help foresters think about this concept of morticulture and managing for those deadwood products, if you will, over time. And I know, it's a little different than the Pacific Northwest where you're at, but as Brad said, you do have experience both in the East and the West, so that's really cool. I guess I'm trying to think of it. Are there tools or concepts that we've talked about that foresters can employ in the field to help them with managing with kind of a morticulture mindset? I know you said that the data or the information is limited, but maybe that would be one place we could start. I know FIA, for example, in the state tracks deadwood on the plots. Is that some information that foresters can tap into in some ways to look at some of the amounts or rates of deadwood in their forest types?
Yeah, they do inventories of both the standing dead trees or snags and the downed dead trees, the logs. So there will be information on that, and it is broken down by type of forest, and probably they also reported by things like counties. At least they do out here. So they may be able to kind of more localize their search through that. So they have information like that. They have information on mortality rates. They do have some causes. Causes are often very hard to determine. Some are obvious, but many are probably multiple things interacting. But they do have some information on that and rates. They I don't, they have various reports, or at least they used to.
Mm-hmm. Yeah.
They probably might break that down by size classes as well. I know they do that for the growth of the forest. So they have both growth and mortality of the forest. They have, like I say, information about the dead wood amounts, and so you get an idea of the variation and the means.
Mm-hmm.
That could be quite useful. In some cases, probably at a research level, because they do experiment with things. They might even have some revisits of particular dead trees, probably standing dead trees more than logs, but that could be quite useful. You might have to work with folks in the FIA to see if that data could be available. Like I said, without a demand, things aren't provided. But if there's a demand for information and they have it, I'm sure the folks there would be very happy to think about, including that, or even, providing that information.
Yeah.
Those are the fundamental things you need to know, how much is being created, what forms are the differences in species and regions, and then some information about what material is there. And, the different states it's in could also help people think about, well, what can I do to match these or change from what I've got to something else?
And I wonder if the thing before the thing here is that they kind of have to know even what they have for deadwood in the systems that they're looking at. Have you seen a lot of foresters integrating, like, say, inventory for this into their standard inventory?
I'm not totally aware, nationwide if that's the case, but I do know that, items like wildlife trees, these are trees that might be larger than average or maybe with broken tops or nesting cavities. Those are often noted. I'm not sure that they're necessarily inventoried, like they would the other trees, but at least their presence. Some people have done inventories of snags and logs. I think the problem is a cost issue, but I think there could be ways to do it in a more qualitative way that would be quite helpful. And some methods are quite quick, like walking a transect and counting logs and diameter classes is not particularly onerous. It's just people aren't used to doing it. So I think it could be incorporated at a number of levels, either somewhat detailed or even qualitative, so people could at least get a sense. And there are even visual photographic systems where someone has actually done a quantitative analysis and photographed a series of sites so that one can just train yourself to look for the amounts of material in a qualitative sense into big classes that could be useful. So there could be a number of ways to do it that aren't that onerous, but I think it's critical information, as you say, to know if you want to know where you're going, you kind of have to know where you are. Without those 2 points of, reference, it's charting the path is pretty hard. If you don't know where you're going, you strike out randomly, then where are you going? And if you just, you don't even know where you're starting, don't know if you're changing or not.
Yeah.
We here in the state, Brad, I have a lot of foresters that may incorporate snags right into their inventory system.
Correct.
I don't often see the downwoody debris or, as you said, Mark, counting of logs on a transect, but that has been done.
Mm-hmm.
And then I like what you said about qualitative assessments, because we try to sometimes, that's for our foresters the most realistic way to incorporate something from a cost and time standpoint is, can you make some observations while you're in cruising the stand, make notes on that to make some kind of an assessment. And it seems like the more foresters do that, the better they get at making those assessments because they're paying attention then.
Yeah, that's a key point. You're paying attention. And actually, you're asking for, better quality through time. So I'm more concerned about the pathways, getting on the pathway, than getting, to the ultimate, version of an inventory right away.
Mm-hmm.
I think it's better to start with small steps in the right direction, and that will provide some critical information.
I'm curious. I've had this experience where we've been out to a timber sale. The timber sale says protect all the snags and, basically keep as many as possible. When you go back afterwards, a lot of those snags are gone.
Yeah.
And when we've talked to people about it, some of it has been, because maybe the forester didn't mark right, the tree that was coming down was going to hit the snag and there was just no way around it. And so it was very hard to preserve that one. But I remember a conversation with a forester and a logger and them talking about OSHA standards and basically having to take down those snags as hazards. Is there a way around that or a way to work with that as a part of timber sales?
Yeah, I think there is. This is a slightly different problem, but related. And we were exploring the idea of green tree retention sales, in which basically we're leaving a substantial number of live trees, not just clear cutting, but actually leaving trees and to some degree snags. And the first response was, well, that's going to be super expensive and, that's going to be difficult. But what's interesting was that if you posed the challenge to the forester, the loggers, they were like, yeah, we can do that. I mean, we're up for it. It's not normal. In fact, it's less boring, and we'd rather do something that involves more of our brain. And so they took it as a point of pride to do things that they were told were not feasible, and they achieved them. Let me go back, though, and just say that if safety is a serious concern, and safety has to be number one. We don't want people hurt, equipment damaged, etc. in any forest operation. No, I don't think anyone wants that. But you can arrange your forest operation so that you can either eliminate all the hazards no matter where you go, or you can concentrate your activities in some areas and leave others aside, in which those hazards really, they're not. Unless you spray in there, that's not hazards. So the other thing is, well, maybe you have to fell those snags. Now you've increased the downed wood component. Can you make it up somehow in the live trees, either deliberately damaging them? And I actually had a group do this. They repeatedly banged logs into a tree in their path. They didn't fell it. It was a live tree, and they damaged it. And their intention was to turn that into a snag. And so, I mean, you can't do that everywhere, but the idea is one can be creative about, replacing the snags that are lost, topping trees deliberately, planned accidents, exposing trees to the wind so that they'll fall down or get snapped. So some of it you just have to, for safety reasons, remove. But you could try to reduce the area that occurs on, and then you can try to offset your losses by either creating snags deliberately or increasing the probability that a tree will die and then replace the snags you lost.
Some of that gets to our retention practices, as you said, and is there ways that we can maybe arrange that retention to protect either snags or areas that are going to develop dead wood? So I guess I was thinking of we've had a lot of conversations, Brad, about this, about aggregated or grouped retention versus dispersed retention. Is that kind of what you were getting at there in terms of trying to have protected areas where you could keep some of that material intact?
Exactly. So if you're going to have a large aggregate that's left, a patch that's not thinned too much or not thinned at all, or there's no harvesting, that could be an area where all those snags could be protected. You don't need to go in there, so don't go in there. That also might lead to more regular input of trees. And on the other hand, out in a more open area, you might leave some trees on their own to either get larger and grow faster and get larger to become sort of the biggest trees in the stand, or they could alternatively be damaged by wind or something and become snags. So you think about it both ways. It's not like this area is going to provide the snags and this one won't. That might be the case, but think of the future too. How could you use those areas where you felled snags to create more snags in the future?
Mm-hmm. We see that a lot here in the Midwest, where we leave dispersed individual trees out in a cut, and just for various reasons they die.
Right.
Whether it's the shock of exposure or more susceptibility to wind damage or insects, we get those snags developing that way oftentimes.
Yep.
Yeah, and so the attitude would be, well, if it survives, that's great. It will become sort of the largest in the cast of tree characters in that stand. Maybe it'll have important wildlife habitat. If it dies standing, it's just created a snag, provides a different habitat. If it gets blown down, instead of saying what a tragedy, it's like, okay, it's now formed a different form of dead wood for us, large continuous piece of dead wood that in a plot of forest that didn't have that before. So it's all gravy, really.
Mm-hmm.
Mark, it makes me think that hopefully foresters listening are going to go, you know what, I should do this. Maybe I've been thinking about, maybe I won't have a better name, like a pulser, right? Like I put a pulse of deadwood in when I do a timber sale, but maybe I'm not really planning for some of that wood to come down the line. So I'm going to start using morticulture. I'm going to be a convert. If we do have converts, what's the one thing you would tell them to keep in mind as they're going forward?
Well, I guess I have kind of a list. Sorry.
Yep. Good.
Lists are good.
Professors never have one thing, do they?
Yeah.
I'm not sure this is in any order, but the first thing, and we've talked about this, is, mortality is a process. It's not a value. And so the value you put it on, it depends on your objectives. So it could be positive or negative. It's very dependent on your context. So just keep that in mind. We've been trained traditionally that mortality is bad. It's going to cause all kinds of problems. And we've lost economic value. We've got to salvage it. We've got to, X, Y, Z. Well, that could be the case on your context, but it could also be an opportunity. So try to change that part of your brain if you can. Learn to roll with the punches, so to speak, to take advantage of natural processes, which silviculturists do. They often, you eliminate weeds and invasive plants sometimes by creating a dense forest that shades out the weeds and the problem plants. I mean, that's kind of a natural process. I think the other thing is, bear in mind, it's a dynamic thing. It's not just it's in and out. So there's an input and an output. That's what makes it dynamic. You can only sort of change things at one point in time. No problem with that. But you can use that input-output idea to envision how it might play out over decades, if not centuries. Certainly over forest rotation. And then the final thing, which is very hard to get a hold of, and it's hard in several senses, but we typically have thought about forests as command and control systems where we command and we control it, when they're kind of a probabilistic system. And that's hard because managers are expected to do something. You have to act to do something. I have no problem with that, but we're dealing with probabilities. So we don't have this deterministic system. So what are analogies? Think about medicine, investments, a whole series of things which we actually deal with probabilities. We have an issue, say a symptom medically. The doctor might say, do this, everything will be fine. But more likely, the doctor will say, well, Is this really a problem? Do we need to solve this? Then they'll propose some treatments. They'll give you ideas of risks, probability of success, probability of complications. Of course, this gets more serious when you get to more serious ailments, but nonetheless, they're always dealing with probabilities. Mm-hmm. And the final thing is it's up to the user. When you've informed them about these things, what is their decision? So I think that's a hard thing because you're an expert in growing trees. You want to give people the best advice, how they should do it. Sometimes people want to be told what to do, but ultimately it's up to the user as to how they want their forests managed.
I think what you're saying there goes back to your initial story about the silviculturist nameplate and your nameplate. And in a way, morticulture is silviculture. It's thinking about those desired future conditions, what those objectives are, and just being thoughtful of how that system works and how we can steer it in that direction, knowing that it is probabilistic. There is lots of variability. So, we just have to realize, it's not going to always be right on target, but that's okay because that's what these systems do. But to be thoughtful about steering towards what those objectives are.
The fellow who I was referring to, command and control, he also said, it's like managing a teenager. You can impose all these rules on teenagers. That may not turn out so well, but you can encourage certain behaviors. You can nudge them in the right direction. You can provide them opportunities that they can take advantage of. And, a lot of teenagers can deal with that. And you can influence teenagers, but it's very hard to tell them what to do. They're becoming independent and they don't want to be told what to do. No. So forests are a little bit like that. They have things that they want to do, so to speak, but we can nudge them and encourage them to go in certain directions. Doesn't always turn out. But you're not just managing one piece of land, you're managing regions, landscapes. So as long as the odds are in your favor, it'll turn out for you more times than not.
Yeah.
Cool.
Good silviculture and words to live by.
Yeah, yeah. And for our teenagers out there. Mark, it was a really great conversation, and I know that it gives foresters something to think about when we're out in the woods and we're developing prescriptions and looking at things maybe in a new light and trying to do a better job of that whole end of the spectrum of what's going on in the forest. So thank you very much for coming to talk with us.
Yep.
Well, I'm very happy to do so. I just want to note that the silviculturists, they're the ones who are going to actually implement these ideas. So I hope this has helped them, and I wish them the best of luck because they're really going to expand the how we think about forests and how we use forests.
Yeah, great conversation.
Cool. Thanks, Mark. You know what time it is, Brad.
Oh, it's time to ride the Silvosaurus. It's time for Silvictionary.
Yes.
And I have the perfect term that I've actually been tossing around in my mind for a while.
Okay, great. Let's hear it.
All right. Well, after our recent episode with Professor or Dr. Ralph Nyland,
yep,
he mentioned a term that I hadn't heard. And when we mentioned it during our stuff, I thought, I got to go back and take a look at that. And so he talked about the idea of when you do a thinning, you actually break it into grades. So like an A grade, B grade, C grade, or D grade thinning.
Mm-hmm. I remember that. Yep.
Yeah, and the more I read about it, I kind of like it because like when we talk about, say, like, at least I do, I talk about like a thinning from below, high thinning, or a low thinning kind of thing like that. And they're basically taking that thinning and putting it on a scale. And so it's more of the intensity of what you're doing. So I think I confused it when we were having our discussion, when he talked about a C grade thinning.
Mm-hmm.
And I think I was mentioned, had in mind like a C line or a B line.
C line, yeah, right, on a stocking chart.
Yeah, but this one's a little bit different. So they basically an intensity. So an A grade thinning is really very light. So it's removing like your dead, dying, or severely overtopped trees, and what you're really doing is maybe just focusing on what's going to die, so there's really not much effect on stand structure.
So it's a light, low thinning?
Very light, minimal removal, and it's really only addressing some of those overtopped or suppressed trees.
Okay.
So it's very light. And it's mainly the suppressed trees you're looking at. In a B grade, you can kind of picture this on a continuum. Here we're removing those suppressed and some intermediate trees. And so we're kind of making progress toward kind of releasing some other things. But here it's really just those suppressed and maybe those weaker intermediates. But again, it's on that lower end of things.
Mm-hmm.
But your dominant trees, your dominant, codominant, they're completely untouched in a B grade. In a C grade, which would be a kind of a moderate, or what we might think of maybe in our terms of like a standard low thinning or thinning from below, this is where you're removing your suppressed, some intermediates, and maybe some low quality codominants, right? So you have those opportunities, you're taking those out. You're probably starting to have an influence on the canopy.
Mm-hmm.
And this is kind of what I think of when we're doing it. So we're probably in this range of like a C grade.
Yeah, that would be pretty common, right?
Yeah. A D then is where we go into a heavy thinning. So this is reaching into the dominance that we use. So we would take out some dominant and codominant trees as well as those lower classes.
Hmm.
And so here you might say, we're going to eliminate non-crop tree dominance. Maybe we have some species that we want to focus on. But in the end, this one's going to open up the canopy much more and more like a thinning from above, but taking out that stuff from below. You're really going to probably accelerate growth on some of those selected trees that are left behind at that in the uppers.
Right.
So to me, it's kind of interesting. It's taking you don't have an A grade going the opposite direction from the canopy coming down, but I still think it's kind of interesting and gives us one more way to communicate what we're trying to do in the forest.
Yeah, honestly, I had not heard that before until Ralph mentioned it. I like, as you said, it's interesting to think of it as a continuum like that, because oftentimes we are using different thinning techniques and kind of scaling them up like that. So yeah, it's interesting.
I could picture like a B grade almost might be like a mid-story removal in some ways. And it's interesting in the B or in the C and D grade, that's where maybe like that actually helps someone actually visualize what you're trying to do when you're putting that thing together. So I kind of like it. I'm going to try to use it a little bit in any event.
Take care, everyone. And as always, thanks to our team, our season sponsors, Family Forest Carbon Program and Nelson Paint Company, Susan Barrett, our editor-in-chief, Joe Rogers, our IT master, theme music by Paul Frater, and of course, UW Stevens Point's Wisconsin Forestry Center.